Hey everyone, this is going to be a very unorthodox video for me. I've got the camera facing towards me on a little tiny tripod. My hand is over here. As you can see, I'm really close in. I am going to build a TinyPICO board on camera for everyone to see. The reason I have it set up this way is because I'm using my magnifying glass like this. I need my magnifying glass to work off. And as you can see, it's going to affect the lighting, but I needed to have the camera out of the way so I could actually work. See my tweezers here. I'll be able to place my parts and see what I'm doing, and you'll be able to kind of watch along. The camera's zoomed in as far as I can possibly get it, so sorry, this is as good as it's going to be. And in terms of lighting, I can't get the lighting down any lower because the magnifying glass is super bright. So I'm going to build a TinyPICO board, but just for reference, here's one I prepared earlier. Oh, how do I get it on the camera? Camera's backwards, remember? So, I apologise. Here is a TinyPICO blinking using JST, using a battery. So, to let everyone know, I've already built one. First build I did on the day that I opened the package, so I did it Sunday night. Today is Monday. Not only did it work, first time with no rework at all on the board, but Wi-Fi works. It's actually as strong, if not stronger, than my Room 32 ESP development board. I know, it's just a hacked-in aerial, hacked-in antenna, I get that. I'm not turning around and making any statements that you don't need to do any network matching. That's not what I'm saying. All I'm saying is the antenna as it is right now, with a single trace with no matching network, does work, and it works quite well. Is it perfect? Absolutely not. I have no idea how much signal is being reflected back again, but it's absolutely working. It charges, it runs off USB, fully programmable, auto reset. That is the board there. It's tiny, TinyPICO. I hand soldered the JST connector on the back. So, I'm going to build one of these on camera right now, and at the end we'll have two of them, so you'll know that I actually did really build one. So yeah, let's go, let's get to it. So here's my board. I'm going to have to stencil. Once again, I'm going to apologise in advance for me being all over the place on the camera, because the camera's reversed for me. So yeah. Okay, let's get our stencil out, our massive stencil. I found a use for my revision 1 Wi-Fi clocks. Okay. Now this is a little bit tricky to do because the stencil's so big I can't lock it in place easily. I've tried, so I have to do it by hand. So let me just get the stenciling out of the way and then we'll have a bit of a chat while I build. Let's get some paste. I think that's a good plan. It's weird seeing everything back to front. Okay. To hold the stencil still, make sure it's registered correctly. So let me just have a look. Okay. Here goes nothing. There's no room around the board anywhere that isn't stenciled. Okay, I will clean this up very quickly. Move this away. Okay, so let's have a look at this board. Try to keep it in the center of the camera as best I can. Okay, that looks good. So, apologise also, I have a sinus infection. I mentioned it that I had a bit of a congestion on my unboxing video, but it's actually a full-on sinus infection, so excuse the way I sound and my nose. There's really not I can do about it. Okay, we're going to start with the CP2104. There's a bit of hair. Okay, Cool. Now I'm going to do the PICO. TinyPICO. Now, unlike the CP2104 where you can actually see the pins on the outside of it, the TinyPICO you can't. The pins are right underneath this footprint, so getting it on and having it straight is super hard. So I put this other one together without my new microscope because it's not here yet. Okay, looks pretty good. Hopefully I won't knock it. So I did it all with this magnifying glass and it went pretty well. I was actually quite happy with how it went. Okay, this is the twin NPN. Now I know my mat is a bit grubby looking. I apologise. I've actually ordered new mats. They're on the way. We'll hopefully have them in about a week or so. Awesome. Okay, I'm going to stick the voltage regulator on. So this is the only other board I'm planning on making of my revision 1. There's one for me and there's one for Matt. Matt is going to start working on getting MicroPython running on it. And I obviously just need it to test and build and do stuff with. Diode. It's a little tiny diode, a new one I'm using. It's to stop V-bus going straight to the battery without going through the charge. I'm just going to do this in all sorts of weird order. That's okay, and whatever it takes to get it on. So I don't want to waste parts making extra revision 1 boards unnecessarily. To let everyone know, I've already designed revision 2. Revision 2 is a complete layout change. Where the header pins are, where all the components are, where the antenna sits. It's got a matching network, lots of changes on it. So, it's the antenna. So I don't want to waste parts on more revision 1 boards than I need. And yes, I know I have 120 boards. It sounds wasteful, I know. But my first thing was, I didn't think I was going to actually get this working first time. And it did, it worked first time. There's only one design flaw on this board, and I'll talk about that later. So I thought I needed to go through quite a few more boards, hacking and breaking things, and I don't. So I don't want to just unnecessarily waste parts for the sake of it. Okay, we'll do the USB last as usual. I'm going to start now putting all the passives on, and there are a lot of passives. I also need to charge IC, so I'll grab one of those. So, as you all know, with panelizing with JLC PCB, panelizing is free. So the cost to send me 120 boards was the same as 10 boards. I thought I was going to need more than 10 boards, but I didn't. So that's why I got 120. So I apologise if that seems wasteful. You can always give some away. Okay, so that's the charge IC on there. So now it is time to put all the passives on. And they're all 0603 and 0402. Okay, so these are 10K 0603s. Got 4 of those, I believe. So on my revision 2 boards, not only is it a complete redesign, but I've moved many of the 0603 parts to 0402 wherever I can save space. Okay, I've got another 10K just here. Now this 10K on the charge IC is to adjust how fast it charges. The smaller the resistor here, the faster the charge. This is set to go to 100 milliamps for charging, which is probably a bit slow. This will do for now. I have another 10K, which I need to put somewhere. Oh, there it is. It's the pull up for the button. Okay, so that's 10K's done. We might as well get the 10 microfarad caps out of the way. Okay, we have 3 of these. So as I said, this is quite comfortable with my magnifying glass. I'm quite surprised actually. I thought it was going to be harder to do. Okay, now I don't have any 0.1 microfarad 0603. That was a mistake. I didn't order. I was supposed to. So I'm going to use a 1 microfarad instead of a 0.1. Now this is just coming off the 3.3 volt regulator, but all of the power going into the ICs have their own 0.1 0402. So not going to be a problem at all. Okay, so now we have 430K discharge resistor. Okay, sorry if my hand was in the way at all there. 430. Okay, now we have some 2Ks, 2Ks and 1K I believe we're going to do. So 1 2K there, I believe. Grab some more. So we're using, these are for the LEDs. Once again, I'm sorry if my hand went in the way. So this is for the red LED for power, just 2.2. And this one is for the orange LED, which is for the charge. So here's my first 0402 part. This is a 1K resistor for the blue LED that is my pin 13 LED. I just followed Adafruit's thing. So the one you can see flashing right now, that is connected directly to pin 13. So this is a little 0402 stuck to my tweezers. These are crazy in size. Okay, it's stuck to the tweezers, need to give them a bit of a clean. Absolutely crazy. Okay, great. Now we need a blue LED, 0603. So it's very convenient having all my parts in front of me now in those blue drawers. Very, very convenient. Okay, so this LED is going to go just here. I know which way it goes, yes. You can see the little green marker when I'm looking with my magnifying glass. Okay, I need a blue, no that was a blue, I need a red. So as you can see, it's a pretty straightforward build. It's pretty cool, I have to say. Quite enjoying working at this size. The hardest part of working at this size is the tweezers actually. It's having the 100K 0603, almost forgot that one. It's working at this size and knocking the parts with the tweezers as you put parts next to each other. That is what I'm finding the hardest at the moment, and I think that I'm going to continue to find that hard as I move down to 0402 everywhere and having parts really close together. Okay, so this is the enable resistor on the LDO. Okay, so I've just got 3 0.1 microfarad caps, 0402, 3 of them. These are a little tricky to put on, or one of them will be anyway. And then I should have one LED left, and and the USB, and I think we're done. Okay, so this is a 0.1. Okay, and then we have 2 next to the PICO. Now this one is so close to the chip that I need to clear my tweezers. I need to roll it into place. So what I do is I put it next to the pads. Assuming it'll get off my tweezers. Yep. That's my phone, and I cannot do anything about it. Okay, it was a hang up. Yay. Okay, so all I have to now do is put on the orange charge LED. This is a different brand LED and uses a different casing, and it's very annoying. I don't know which way is the right way. So the other 2 LEDs were, yeah, okay, so that's positive there. The other LEDs were clearly marked on the top, but this one is not marked on the top, and I hope I put this on the right way. If not, I can turn it around. So that's everything other than the USB. Okay, let's do a quick look over the board. Make sure that everything is as square as I can get it. So I can move the PICO over a bit. Okay, good. Okay, I'm pretty happy with that. Let's put it in the oven. Oven is on. I'm going to put this on a board. Just put my light out of the way, just so it's easier to carry and take in and out, and so it doesn't fall through the oven rack. Okay, it's time to reflow. While it's reflowing, let's have a look at this again. So, I'm extremely happy with the way this has turned out. Let's just get the way around so you can see it easily. Get some more light down, I think. Let's talk about the one mistake that's on this board. I broke out pin 16, GPIO 16, and on the Room 32 that's fine, but on the PICO D4, 16 and 17 are reserved for use with flash, so you can't actually use them as an I/O, and I didn't realise that. It was my own mistake. I hadn't checked thoroughly on the data sheet, and so I broke out 16, and 16 is the second last one over here. So on my revision 2 it's completely different now. And I've got a whole lot of other GPIO. So this has got 13 GPIO broken out, of which obviously one we can't use. And my new board has 15. So revision 2 has 15 broken out, which you can use them all. So there's also a lot of other changes to the revision 2 board other than just a complete rearrange of components and repositioning of components. There's some other features I've put onto the board as well, which I will go through when we get up to the revision 2. The board is pretty much ready to go into PCB manufacturing. The only thing I was really waiting for was whether these worked or not, whether I had an issue with any of the components that are on here. So the board itself draws 45 milliamps when it's connected to USB without a battery plugged in, with it just sitting running some code, which is pretty good. It's about the same as what I'm getting on my Room 32, but it's about 15 milliamps less than I'm getting on a Wemos D1 Mini. So it's better optimized than a D1 Mini, which is great. I'm not really sure whether there's any of these components I could really swap out and make them any better, any lower power. Like the LDO's got a 55 microamp quiescent current. I found some other LDOs that are cheaper and a couple of them more expensive, but their quiescent current is sitting up at around 65 to 75. One of them was even 95. So this is quite an optimized LDO. I'm not really sure what else I could change on this here to get it even lower power than what it is. But there it is. Anyway, we're reflowing. We're about halfway at the moment. Let that just sit there. I'm sure people are going to have a lot of questions about this, so I guess on my stream tomorrow we'll be discussing it. Oh, there goes an ambulance or a police car. I'm happy to field any questions about this tomorrow, or any comments that come up from this video. I'm also happy to answer. 0402 is tiny, but definitely manageable. Okay, oven beep. Okay, I'm just managing the oven door at the moment. Okay, better get this ready. So I'm just going to swap this out. Can I line this up a bit better? See if I can line this up on the camera view. Okay, oven door's fully open. The pliers ready. And we're done. The reflow is finished. Carefully get the board out. Slide it in. Let's get it back in the middle so everyone can see it. So let's have a look at this while it's cooling down. See if I can get my magnifying glass close enough. I'm just going to have to move it. Well, it looks pretty good. I'm going to turn my iron on, and I'll explain why in a moment. PICO looks like it's potentially fine. It's really hard to tell because obviously it's underneath. No visible shorts on the CP2104 or anywhere else. Okay, cool. It's cooled down. Get it back in the middle again. Okay, what I'm going to do is a little trick I've learnt. These USBs. The USBs are actually pretty good, except, yes, I've knocked them off a few times, or I've ripped them off. What I'm going to do is solder the side pins down. That's what I've been doing now. So it just turns out that the solder mask for the footprint doesn't leave enough solder on the side tabs, and that's why there's no mechanical stability there. So I'm going to manually solder those side tabs. So it's a bit harder because the button is there. Cool. And that will keep it in place when I plug in and unplug the USB. So, 2 boards. There we go. Just so people know there's no trickery. That one's got JST on the bottom. That one obviously doesn't. So, I guess we should grab a USB cable. Let's go move to my other desk. Okay, here's the TinyPICO. I brought it in next to the Wemos D1 Mini and my regular ESP32 development board. I'm just at my standing desk at the moment. So I just wanted to bring it here just for skies, so you can see the scale of it. And as you can see, it fits nicely inside the D1 Mini shape. Pretty cool. Okay, let's move this out of the way. Let's get a USB cable. Okay. And let's see if we can plug it in live. Live meaning in front of the camera. Hopefully a power light will come on. Yes. Good. Power light's on. As you can see, there's a slight flashing of the orange LED. That's the charge circuitry does that. If there was a battery plugged in, it'd obviously be solid for charging or off for not. But with no battery plugged in, it just sits there flashing. Okay, let's see if we can program it. Let's hope that it appears in our list. Tools, boards. I need to choose ESP32 PICO kit. I can't just use a normal ESP32 board for this. It's got to be a PICO because there's different flash configuration. Okay, and port, there it is, slab, USB to UART. Cool, so let's go blink. I've set up pin 13 for blink. Compiling. Okay, it's compiling now. Okay, it's connecting, there it goes. And hopefully we've got a blink. So we now have 2 blinking TinyPICOs. One off a battery, one off USB. How exciting is that? Okay, so I'm just going to unplug this one just for a moment. And I'm going to just plug the USB. So you can see that the JST connector is on the back. But I've put it in such a place that the USB can also plug in at the same time. So now you can see it's charging. We've got the USB and the JST connected at the same time. And there's enough room that you can pull out the JST if you need to. Here we go. That's now just, you can see it's a little flashing. There's no battery in there. And I can plug the battery in. Make sure I plug it in the right way around. It's hard doing this back to front. Silly camera placement. Okay, I'm just going to do it normally. Won't be a second. Here we go. Right. I'm right-handed. I can't do it upside down. There it is. We're charging. So, we have 1 blinking TinyPICO, 2 blinking TinyPICOs. This one's for Matt. Hey Matt, this one's for you. So you can put MicroPython on it and have a play. Let me know if you want me to put a JST connector on the back of it for you. Or you can put one. I'll provide one. You can hand solder it on if you want. 2 TinyPICOs. Thanks for watching, folks. If you like this video, please give it a thumbs up. If you're a new sub, welcome. If you haven't subbed to the channel, please sub. Why not? And for all my existing subs, thank you very much. To all my patrons, thank you. Your help makes it possible for me to afford to buy all of these things. So thank you very much. I appreciate it. Catch you all next time. Bye. Blinky, 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 blinky.